Whenever we look at irrigation, first thing I ask people is, okay, what's your water source? And that makes a big difference. Then how many acres you trying to irrigate? You try to determine and eliminate guesswork. And so you say, okay, surface water, storage tanks. More and more people are going from storage tanks because they say, I don't have water rights. I'm going to truck the water in. Well, okay, do you know how much water you really need? And a lot of them haven't a clue. Water quality, what do we need to filter out? If we're doing drip or micro irrigation, that's important. What crop length are we talking? If it's 2 weeks, probably you don't want to mess around with drip. Overhead might be better, but if you're irrigating the season, yeah. Big gun traveler, pros and cons. Puts a lot of water down fast and hard, packs the ground. A lot of people hate it for that reason, but it's more labor friendly. Linear pivot, cost goes up, but you can get a lighter application. The problem there is when you figure out on most pivots, as the water moves around, at the end of that pivot, the water's coming down as fast and hard as what it would in a big gun traveler, because you're trying to get a certain amount of water on at a certain amount of time. So you got to watch wheel lines. The problem there, I had somebody talking this morning from Daystar Academy. They have wheel lines that leak a lot. The thing to look at there, and at the end of the slideshow, I'll have a few references for you to check out. A lot of times if you're irrigating with wheel lines, your drains will leak, your gaskets will leak, your sprinklers may be getting wore out and leak, levelers may leak. A lot of times your utility district or your state will have a program here in Oregon. It's called Energy Trust of Oregon, and it's paid for by your utility district. And if they're not part of it, then the utility district will also participate and give you money for gaskets, upgrading systems. So it's things to check out. If you're irrigating with sprinklers now, you may look at checking with a lot of the resources we'll cover at the end of the topic of helping them fund your project. Hand lines, same thing. Labor, unless you solid set, and a lot of crops are solid set in the area. Onions, especially, most of those are solid set in this area. Other areas, they're tape. Micro sprinklers, we're seeing a lot of that in the new plantings, the hazelnuts and smaller crops like that to where they want a larger wetted pattern. Drip tube, drip tape. Lay of the land is probably the biggest thing on drip is, do you have slopes? Are the slopes too excessive to use it? Filtration-wise, what are we filtering out? Are we filtering out sand, algae? A lot of that depends. Sand media filter, if you got light sand, algae, they're great. They're heavy. They're expensive to maintain. Take a lot of water to flush. Disc filter, there's manual and automatic on those. Those are good for algae, organics, because they have a larger path that takes the stuff through, and we'll cover all these topics. Screen, same thing. There's automatic and manual. How many of you know what soil water holding capacity is? I used to not know what that is either. Basically, if you go to Soil Web Survey, they will allow you to map out your piece of ground you're trying to farm, and you can tell how much water is going to be held, and it's based on soil particle size. So in one field, you may have 4 different types of soil. Each one may hold a different amount. Rule of thumb is the average soil that I've worked with in this area, about a 0.2 inches per inch of water holding capacity. And so your root depth, we figure about 18 inches. So you calculate it out and you say, okay, that's how much water we have available. Once we get that depleted out, then we're And the water holding capacity is similar to taking a sponge, and you soak it in a bucket, and you hold it up and let it drip till the water stops running out. And what's left in that sponge is what the water holding capacity of that soil is. So when you start getting to the wilting point, that's where your plant roots can't extract any more water out of that soil, and they start to wilt. So we like to replenish it before it gets that far. Agromet is a weather station put on by most of your local NRCS type people, and by going to that, you can tell what your ET rate is each day for the type of crop you're growing, or a crop that you know is similar to what you're growing. I was just at a hazelnut meeting yesterday, and the research doesn't tell them how much water a hazelnut uses, but fortunately with the people I've worked with that use soil moisture monitoring, we figure out about a quarter inch a day, about 7 inches a year is pretty close to what it takes. And so that's a good resource for research. Web Soil Survey. That tells you your soil types. That happens to be a picture of one of the fields that I have in grass right now. And as you can see, I've got 3 different types of soil in that one field. And so each one reacts a little differently. And that's what the map shows. In actuality, I probably got more, because I have different spots that I can tell when I'm out there working the ground. It doesn't behave the same as other spots. But that's a good, useful tool to outline things for you. And there's the report that you can get by soil type. It tells you available water capacity. And based on what your crop uses, that will tell you how much water is available and how soon you need to replenish. And if you're working with drip irrigation, you like to put it on daily what's used, because if you go to the wilting point and have to put it back on, a lot of times if you're in sandier soil, it's going to want to channel down as fast as it can. It's not going to stay in the soil profile like it should. Then you have to start what they call pulse irrigate, and what means 5 minutes on, 20 minutes off, 5 minutes on, 20 minutes off, to try to push the water sideways in the soil to fill that capacity back up. Dryland farming. How many of you have tried vegetable gardening, dryland farming? One of the first customers that I had worked with, it's been 25, 30 years ago, didn't know what irrigation was. Raised produce that he hauled to Portland to the produce market. Never irrigated. Potatoes, root crops, no problem. Then he went to irrigation. Your yield went up. Quality was about the same. Because when you have healthy soil, your water is not as big an issue. And they've been, Oregon State's done quite a few trials on dryland vegetable farming. Dryland farming means no supplemental water. So in other words, you work the field, prevent compaction, improve the tilth of that soil to where your ability to store water is enough to make the plant survive the season and give a decent yield. My granddad always used to talk about, got to mulch the soil. Got to mulch the soil. And I didn't quite understand what he was talking about, but when you work with soil, you can control your evaporation and capillary action of that soil. You have a water stored in the soil that percolates up in capillary action. What he was talking about by mulch is back in the days of horse farming, they would try to get a 1-inch powder mulch on top of the soil of fine soil particles. That would break the capillary action so the ground would hold the water better for the season. And so that a lot of people have gotten away from that because they're used to being able to dump as much water as they can on the ground, and that helps out. Drip versus overhead. The biggest thing there you got to look at is which is better. A lot depends on the money you have. What's it take to start out? Some people will start out with overhead and graduate to drip. If you're using overhead right now, you may say, okay, that's working for me. What can I do? I'd like to go to drip because I think it would save me money. I could put nutrients on as we go. Look at the resources available to you to convert to drip. Go to the NRCS website for your area. Go to your soil and water conservation districts. See what might be available. And a lot of times they will cost share the whole project, but you got to get their permission before you start or they don't pay you a dime. Overhead irrigation is great for cooling. If you're irrigating I talked to somebody today from Texas, Utah, any place like that to where you have wind, high temperatures, overhead irrigation is not as good as it could be because you're trying to cool the air and evaporating the water off before it ever gets to the ground. A lot of crops are susceptible to bacterial blights with water applied from overhead. We've had some guys with blueberries that are irrigating overhead that are going to drip, and then others go the other way because they say, no, we got to cool the crop. So, a lot depends on the crop you're trying to grow. Filtration-wise, probably the Deluxe is a sand media filter, just because of the ability to filter more out, but it's more costly. One thing most people fail to realize on a filter system is that the automatic ones need a backwash. If you're flowing about what the crop requires through the filter system and it goes into backwash, your pressure drops. Once you drop below about 35 psi, your ability to flush that filter properly is not there, and it can start causing some issues. Anytime I use surface water, I prefer to use sand media filter. Most of the time, people can't afford it, so we end up going with a flushing screen filter that'll do just about the same, depending on what crops. The biggest thing is algae with a screen filter is if you have algae and it starts to hang in the screen, time you get a pressure differential and the nozzles rotate around, sometimes they'll trim that off and a piece of that algae will float down the line. So unless you're treating your drip, you may end up plugging. So one of the questions in my other seminar, people says, what's your thoughts on using gray water for irrigating? You say, okay, what do you mean by gray water? Example, city of Canby where I work, I tend to pack my water because I don't want to drink it, because I've talked to the guys in the water treatment plant, and I says, how good is the water? I says, do you detect any antibiotics or stuff like that in it? Oh, yes, we do. So, that's something to look at if you're looking for marketing a crop. Are you growing a healthy crop using some surface water? Are you, because if you're getting antibiotics from people's tablets, they flush down the toilet or exposed that way, and they're sucking that river water up and treating it. They say, yes, it meets all state standards, but they can still detect different antibiotics in it. Is it really the best water you can irrigate your crop with that you can feel comfortable eating? Protecting drip system is all about filtration. So if you have a good screen filter, like on the picture on the left, that helps keep you from sucking up too much stuff. You might have settling ponds or a pre-filter before you go to another screen. That helps. I've had systems where we put them in. The well, they said it's been reconditioned. Don't pump any sand. Then they called me up and says, hey, our filter's plugging with sand. I said, I thought you said you didn't have any sand. Well, we thought we didn't either. And some of that has to do with If you're pumping from a well and you pump sand, is that sand coming when you first fire up, or is it pumping sand all the time? If it's pumping sand just when you fire up, you're drawing from that aquifer real strong, and chances are what's happening there is that you're over pumping the aquifer. So if you were to slow the fill rate of your pipeline when you're starting up, you can probably get a VFD drive that says, okay, we got a line fill mode, so we're going to slow that process of filling the line by putting a pressure sustaining valve on the backside of the filter. That's going to help the filter, so if it goes into backwash, it's got the pressure needed to filter, and you're going to improve your water quality and be able to manage your system better. Drip systems. In the last class, somebody says, well, tell me about these boat emitters. Well, in the bottom corner is a boat emitter, and it has a little diaphragm, and it's got a little trash screen on top, and that's what they call a boat emitter versus a cylindrical emitter. What happens, they help protect the line. Most everybody's going to a boat emitter because it's more cost effective, because they can use that same emitter for any size tubing they make. So if they start out on tape a 5/8, a 7/8, a 1 inch, they can use the same emitter. On the drip tubing, same thing, anywhere from the 15 millimeter all the way up to the 22 millimeter. You can use the same one, so they don't need to stock so many parts to put a system together. Your biggest friend on a drip system is monitoring the health. And the easiest way to monitor health is when you first put that system in. If you have a water meter, good pressure gauges, good filtration, and you take a reading on each zone you irrigate, you can say, okay, we know that we're taking 100 gallons a minute. 2 months from now, we take a reading, well, we're taking 110 gallons a minute. Okay, what's happening? Do you have a leak in the system somewhere that you need to go out and track? Or are you wearing orifices bigger so it's taking more water? So a water meter is probably one of your best defenses for starting to check out and then making sure you're flushing your laterals, because if your water quantity is starting to drop, say if you're down to 75 gallons a minute instead of the 100, you're plugging emission devices. So then you say, okay, what do? We need to flush the main lines, inject cleaners in, and I know a lot of you are organic, and you say, oh, we can't use this, we can't use that. Then that's an issue that you got to find out what kind of a chemical can we put in there to help clean the emission devices that's still approved by a lot of the organic people. So when you look at an emission device versus a micro sprinkler, the orifice size is a whole lot bigger on a micro sprinkler. So if you have bad water, look toward the larger hole if you can. But if it's due to the crop you're raising, if that's not possible, then you just got to manage with filtration to try to get the water quality to where you need it. So filters, we've sort of halfway covered that. They will fail. I had one farmer that he's using a screen filter, calls me up, says, I got a problem. I said, what's the problem? He says, my filter's coming apart. I said, okay, I'll come out. So I went out there, and it's a stainless steel outer shell with a fine mesh screen bonded to the inside. And it has little sweeper nozzles that rotate around to clean the screen off when it goes through a backwash. Somehow, and we don't know how, he got 2 rocks in that filter. And he says, well, I was hearing a clunking noise when it was running. Didn't bother to take anything apart, and it ended up taking 4 holes in the screen. And so he has to spend about $1,000 to get a new screen. And so that he says, well, we'll just try to work that out in the future. So how fine a screen do you really need? It all depends on what you're working on. And mesh and micron Mesh, as the number goes up, the screen size gets smaller because it's the number of wires per inch. Micron, on the other hand, as the number goes down, the particle size has to be finer to get through. So you can go down to 1 micron, and that's what water treatment uses a lot of times. How much TSS, total suspended solids, which might be clay particles. I've fired up sand media systems in the springtime where the ponds have been murky and the water coming out, going to the lines is murky, which tells me when they shut down and that sets, that sediment's going to settle out. And so fortunately on that system, they do double filtration. They filter at the pump site and they filter in the field at the zone. That way, just in case they break a main line and they put a repair in, if they didn't get all the pieces out, that secondary filter is going to catch it before it gets into the drip system. The TDS, total dissolved solids, that's a number that is somewhat relevant because the higher the number, the more issues you may have trying to filter it out. And it's a matter of figuring out what are those solids that are dissolved. So basically at the bottom on the left we have the sand separator. Those are troublesome with the new VFD drives because as you slow a pump down, your speed going in is slow, and so you're not getting the centrifugal action to spin the particles out to drop into the bottom can. Sand media filter, if your pressure differential isn't right, you can start getting some packing and buildup, and I've had some issues on some of those east of the mountains. Top one's a disc filter, great for taking organic stuff out, very bad for taking sand out, because if you take them apart and pieces of sand get in there, you start getting bigger filtration area than what you want. Bottom's green, prone to plugging. So basically, what are you looking for in a filter? It's a matter of how much money do you have to spend. We can get the water as clean as you want it, depending on how much you want to spend. And so a lot of times you say, okay, what's the best system that we can put in to do the job without a lot of trouble? Most of your sand media filter in the bottom, they've got, at the upper right, you'll see these little wedge wire, is what they call it, that help filter out the particles from getting through. And then when you go through a backwash, it fluffs the bed back up. The one under is a screen filter of sorts. Closer look at your disc, you can see the tortuous path that has to go through. It's a wider area, so if you're working with algae, they're less apt to get driven through like they would on a screen on the other side there. Filter cake, that's when you allow that sand media filter to absorb too many solids. And if you absorb enough, and if you don't have the right pressure and water available to backwash, you'll have what they call caking, and it's not going to filter well. It's going to start to channel, and it'll cause lots of issues. And so sometimes you'll even have to open up the inspection port and get in there with a shovel or a rake and break that top surface up and then do several back flushes to get it going. So there's rough internals of a sand media filter. On the left is when it's in operation. The water comes from the top, goes down through out to the field. When it goes into backwash, you need enough water to lift that bed to purge the particles out that would be caking in the top of it. We've already went through most of the sand media portion there. On your filter media, if you look at it, they told me I had a pointer here somewhere. They've got either a motor or a screw that works to turn nozzles, and those nozzles will rotate and clean the inside of that screen. The one I sell quite a bit of is an Olson filter made out of California. 15 seconds for a recycle and takes about 15 gallons at most on a big filter. A small filter, maybe only 5 gallons. And so if you're limited in water, that's and it will work, that's a good one to look at. far as putting tape in, most people say, do I lay it on top or do I inject it in the ground? If it's a short-term crop, laying on top might be okay if you don't have rodents, insects, or stuff crawling on top of the ground. Otherwise, you're better off if you're injected at least an inch in. California, a lot of times they'll be injecting that 12 inches down. That way they can farm over the top of it. They have everything laid in with GPS, so when they farm, they know where they can run their tractors and where they can't. So that way they're not packing on top of where the tape is laid. That's a gopher damage on that. We've had it to where we have seen insect damage on a nursery. They fumigated the ground to kill everything, planted trees and put tape in. The next March when they went to irrigate, they had leaks. And get to looking at it, and you see these little rough, jagged edges in the center, not on the edge. Gophers usually will eat off the edge. Insects will actually dig out the middle of the tape. So you just got to watch what you have in the soil and realize that tape is thin. If you have a big pressure on insects, heavier mill works. Gophers, it don't matter how thick, they're going to eat it. How many of you are familiar with the way water works in soil? On the far left, before irrigation, where your tubing is, there's a little bit of moisture. You put some irrigation on, and it starts to want to drop down. If you shut off, it starts to spread sideways. And if the more sand you have in your soil, the harder it is to push that water sideways. And that's where pulse irrigation comes in a lot more. Water meter's your friendly device. It's going to be monitoring the health of your field. Some places it's required by water resources to keep track how much water you're taking out of the soil or out of the ground or streams. Injection. How many of you like to inject stuff into your drip? Which method do you like the best? Any response? The top one is an LMI. The bottom one's a stenner. The stenner basically is looks like a piece of surgical tubing that a roller runs around, and it gives you a positive placement. The top one's more of a pump that actually pumps based on flow into the system. Either one works fine. There's some applications where guys want to put more on than either of those two will. Then you have to look for a regular pump that's going to overcome the pressure in the main line to pump in the quantity that you need to pump in. So when you look at it, whenever you start working with injecting, make sure you got a backflow device of some sort. They make chemigation valve backflow devices. Need a vacuum breaker somewhere so you got a spot to suck air so you're not sucking backwards on the system. Check valves on your chemicals so that when things shut off, you're not going to have water flowing back into your tank and overflowing it. Pressure reducing valves this happens to be a Mozzie style siphon or Venturi style injector. Least expensive way to get started. A lot of people work with them. They find them very well. But like I say, what I've started to experience is people wanting to inject more and more stuff in as time goes on. Okay, resources to consider. NRCS, Soil and Water, Energy Trust, local PUD are all sources that can help with cost share. You just got to see what's available. I was talking with an NRCS rep yesterday, and he said that if you go to NRCS and to your state, they have a tool that will show you what's available for your area. If you happen to be in a critical groundwater area, they may help switch to drip irrigation or improvements on the system to stop leaks or whatever. So don't rule out any source. Keep looking. There's always people willing to give you money if you know where to look. I know NRCS there for a while was paying a good portion of the cost of a high tunnel if you're willing to put one in this area, so you can grow a longer season. So there's a map that I was talking about, the NRCS. I just thought I'd do one of Oregon. And if you were to click on any of those shaded areas, they would tell you what programs are available in those areas. So if you find your state and go to it, you can see what's available in your area. I don't know if many of you get into greenhouses, but the Toro Evolution timer is probably one of the best because it does have a misting feature. In other words, you can have so many seconds on and 5 minutes off and have it go in a loop. And if you're from a warm climate, it's one that you can have it do one. You have it start like at 6 in the morning and have one schedule till noon, and then switch to a different schedule for the afternoon and shut off at night. So it makes it very easy to, when you're trying to propagate something in a hotter climate, to where you can have that moisture content keep where it is, and they're fairly easy to program. And I think we've sold those for 4 years now, and we've had 2 that we've returned. One to be reprogrammed or reflashed, and one was broken when we got it because there was a part rattling. So not much problem with those. If you get into designing, Toro, you can go online to their website. They have a tool to where you can get there and start plugging in tape lengths, elevations, run lengths, and it'll give you a chart like the one there in the middle. And basically what that tells you is what your uniformity is. I don't like to see more than maybe 2 colors maximum. I was working on one earlier this week where I had 7 different colors. Hillside for drip, and it wasn't going to work well at all. And they also have another one where you can calculate some of the other stuff. You know, resources on the internet are great nowadays. So if you don't have a irrigation dealer close by that can do it for you, all you have to do is look online, and you can a lot of times get the resources you need. Okay, sprinklers. There's more and more people trying to get into that market, and what's the best out there? I guess what I'd have to say there is look at the crop you're trying to grow. Look at your weather conditions that you're looking at. I know you're from Utah. With the wind blowing, and with if you're trying to shoot a fine droplet through the air, you're going to probably lose at least 50% through evaporation and blowing off target. So in an application like that, I'd say, okay, let's look for one that produces a little coarser droplet, but not too coarse, that would get most of the water to the ground without much evaporation. And a lot of times in the high wind areas, they'll look at low angle sprinklers so that we're not traveling through the air quite as much. And that helps also. And rotaries, some of them are designed, like Nelson Irrigation, they make their rotaries designed to shoot further in wind areas without distorting the pattern as much as what some of the impacts would do. Any place where you're throwing water, you're especially can yards, you try to go head-to-head coverage just to get a uniform application. When you go to the field irrigation, you assume that the outer third of your irrigated, wetted width is not irrigated fully, so you need to make sure that other sprinkler from the next set covers that third. And so that's why a lot of times, depending on the location you're at, we've seen anywhere from 40 to 60 foot between sets, and what we find is the ones that have the 40-foot sets usually have a better job of coverage. You get to the drier areas, your pipe are usually only 30 feet long instead of 40 feet long, so that helps too. So it is a matter of trying to get head-to-head coverage, with the head-to-head, if you have wind blowing, chances are you're not blowing so far off target if you're doing them in zones that it's going to affect your crop. NRCS, if you go to the NRCS national website, Then the map, when you click on that, it shows the whole USA, and then you click on your state, and then it will bring you to the map that I just showed you. That was okay. The question was, when you're working with a stream that has algae, and you have a filter that tends to plug a lot, for a small farm, is there a cost-effective way to improve your filtration without breaking the bank? The answer there is yes, sort of. I know that at Willamette River, it has an algae bloom usually in May, June, and it will turn things green quickly. We've got a lot of nurseries that run recycled water that have issues with plugging. What we've done for some of them is we'll take that small filter and maybe put 3 of them in a row in a manifold with valving so that you can shut off one and service it while you're still running with the others, and then put that back in line, go through all 3 of them, and you'll get maybe 3 times the run length. And what also is happening is, in fact, you've slowed the velocity down across the screen, so you're not trying to drive this stuff through the screen, so it will work better and longer for you. It depends on what you have available and what you can afford. You know, if your main concern is just the algae, if you have no sand particles, then I would say the screen filter, the disc filter would be better. If you have any sand, what happens is when you go to wash that filter out, if any sand particle gets caught between the high spots of the disc when you clamp it back together, you've increased the width of your filter, and so you can plug quicker. So if you're just filtering algae out, it works fine with a disc filter. You could stack the disc filters up. The thing you got to look at is screen filter versus disc filter. Screen filter, usually you put the water inside and force it out. On a disc filter, you're taking the water from the outside and forcing it to the center and out. And so if you switch, you know, like Amiad, they make both using the same housing. So the only difference is the direction of flow they get hooked up. The boat emitters I'm talking about are ones that are bonded inside the tubing. So it's not ones that you are going to be poking in yourself. That's a good question. I got a pivot. I got an alfalfa field. What's the best sprinkler? What's the best height? Question for you. What location?
Eastern Oregon.
Okay. Got a lot of wind?
Yes.
Okay. What you look at there is what sprinkler works the best, and they're starting to do more and more of, I don't know if you're familiar with LIPA hoses. They basically drag the hose on the ground and let the water out.
I have seen that, yes.
And that is one thing that some people are trying. I know they've tried it in corn. It works somewhat, but not as good as they thought it would. The idea is trying to get the water to the ground without flying through the air and to keep above the crop. And so you sit there and you go, okay, with alfalfa, you're probably not getting over 2 foot high. So the lower you can get that sprinkler, then you got to watch your spacing, because if you're getting closer to the ground, you don't have the distance to arch that before it hits the ground. So you have to look at a little bit of the sprinkler design to see which one works the best for the height you are above the ground. Well, when I used to sell pivots, I always viewed the wobblers as a wore-out rotator. but that was my opinion. But most all of them have wobblers. The biggest thing you got to look at is your infiltration rate on a pivot or linear, is because of the fact on a pivot, your outside is moving so fast compared to the inside. How far can I spread that water out so that I'm not hitting one spot so much at once? Because if you're dumping that inch or two of water on all at once, is that ground going to be able to soak it in properly? And so the further out you put it, and whether you use boom backs forward and backward of the machine to get those sprinklers spread out in a further pattern, that makes a difference also. I believe in something simple, you know, in the wobbler. I think Nelson has one now, the IWOB, and IWOB is Senator. But all the makers of sprinklers try to come up with something that's going to Keep the droplet size fairly big so it doesn't evaporate before it hits the ground, but you want it to spread out wide enough that you can get more surface area covered with that pattern to allow that water to soak in on target.